So everybody, welcome to another session of the webinar, Beginning Performance Tuning. My name is Arup Nanda. I think my biggest qualification is that I have been an Oracle DBA for a very long time. In fact, 19 years. That's all I've been doing. My first job was taking care of an Oracle database, and today I do something bigger than that, but at the end of the day, that's exactly what I do. And I grew with Oracle. And to talk about everything from modeling to performance tuning to disaster recovery, I've done that all. But I'm always a beginner, as always. A little bit I have to tell you before this session starts. This is entirely for beginners. This is not at all for even for intermediate also. So if you are pretty comfortable or you're a little bit advanced in performance tuning, this is not for you. But this is not Oracle beginner. So I'm assuming you know something about Oracle. It's just a beginner for performance tuning. That's the important part of it. So I apologize in advance if you are there, but you happen to know a lot of stuff I'm going to cover because I'm assuming you probably have little information in the beginning of performance tuning itself. Agenda. First, you might have seen that several times in your job or somewhere else. You certainly noticed some degradation of performance. Well, the question is, what exactly do you do next? So I've seen people doing all kinds of stuff. For example, somebody sets up a top session. Somebody goes to AWR report and get it, and all that thing. So these are all haphazard methods. So if people don't have put a lot of thought into exactly what they should do and what they're looking for, and based on whatever they find when they look for something, what does do next? Where do you start? So exactly what do you pull up in the first place? And what kind of tools do you have to use? So these are the questions you got to understand, and that's exactly what I'll be talking to you about, is that how do you start doing some kind of a performance troubleshooting, and what are the tools you can use, and how to understand the root cause. It's important to understand the difference between root cause and symptoms. For example, let's say you have a fever and your temperature is very high, let's say 105 degrees something. That's not the problem, that's a symptom. The problem could be if you have an infection, you were out in the cold for a long time, there could be all kinds of things, but the temperature is not the problem, it's the symptom. So it's important to understand the difference between a symptom and the root cause of it. And again, in this session today, you'll be able to identify you'll be able to learn how to identify the root cause and differentiate it from the symptoms. What are the tools? Well, here's a good part of it, is that there is absolutely nothing to buy. We'll be using my favorite tool, SQL Plus, and we'll be using some internal Oracle supplied utilities that are available to you. Some of the utilities may be an extra cost option with Oracle, but you may already have it. If you don't have them, that's fine too. It's not the end of the world. We'll come to see why that is the case. For the next one. So why do most troubleshooting actually fails? And I've seen that, first of all, people approach it in a haphazard manner, not in a systematic or methodical. As I said earlier, let's say there's a performance problem right now. Somebody pulls up an AWR report, somebody pulls up a top session without knowing what exactly are they looking for in that top session or the AWR report. That could be the right thing to look at, but if you don't know what exactly you're looking for, it kind of is a moot point. That's one of the reasons why troubleshooting fails all the time. Second, not looking for the stuff at the right places. You cannot find out CPU statistics on an AWR report. That's not something you can do that. A third one is confusing symptoms with the causes. As I gave the example of a fever, your temperature is nothing but a symptom. The root cause of the problem is going to be fever. So you've got to understand how do you reduce the temperature and how do you remove the root cause of it. So don't confuse symptoms with causes. These are the primary reasons I've seen the performance troubleshooting efforts fail miserably. And that's exactly what is to be avoided. Let's see if we can do that. Well, principle number one, always keep that in mind. Measure your challenge. This is very important that before you start any kind of troubleshooting, you got to understand what exactly you are going to accomplish in a numerical term. Doesn't have to be numerical, could be also some language, but in a straight sentence, non-numerical sentence, but it got to be something you can put it down on. Let's say you're trying to reduce weight. You're trying to be healthier or fitter or better. You want to do that. What is the first thing you should do? Well, get on that weighing machine or a scale and find out how much you weigh right now. Only then you can find out what you should do to improve it. So if you don't do that, you can't really figure out, well, at least not objectively, what are you doing the right thing, doing the wrong thing, whatever you are doing is working for you, not working for you, making it worse, all the thing. If it is the same thing as a fever, put a thermometer into your mouth and find out what's the temperature right now. After you take the medicine or remove the root cause, again you find out. So it's important that you have to measure your challenge. If you cannot measure it, you cannot tune it. Very simple thing. Because it's not a matter of opinion. It's a simple question of numerical methods to do that. So, being said that, is there a way we can apply that principle to practice? Yes, we can. That's the next one. There are actually 3 different approaches to doing this numerical assessment of a problem in Oracle. The first one is called time-based accounting. For example, it says what happened. For example, a block was retrieved. 16 blocks were retrieved from the disk to the buffer cache. No rows were returned, etc. But what's also important is that how much time was spent on each one of them. So for example, to retrieve a block, first it used to take 5 milliseconds, but this time it took 25 milliseconds. Well, there is a problem right there. So we'll find out exactly why the problem happened in the first place, but that's how you do called time accounting. The next one is called wait accounting. So we'll actually cover that a little bit later right now. So it goes with the principle of what is the session, Oracle session, is waiting on right now. For example, it's waiting for a block to be available. How much time is already waited, or how much time it waited in the past. Right now it's not waiting. And the third one is called resource accounting. Now all these things are time accounting or time-based accounting, but doesn't take into account other factors. Everything that runs on a computer takes some resources. For example, CPU, memory, I/O bandwidth, etc. So in this case, what happens in resource accounting is you have to find out how much resource was consumed as a result of this thing. For example, we consumed 10% of CPU, 20% of CPU, etc. How many logical, how many number of buffers were retrieved, etc., etc. It's not time-based. It's simply amount of the data, or amount of the resources consumed as a result of that. It could also be something Oracle specific. For example, number of latches obtained as a result of that, or logical IOs obtained as a result of that, number of redo locks generated as a result of the activity, etc. So it's not time, it's the resource accounting. You'll see that all 3 of them are extremely important, and I will see exactly why they're important in the next one. So the first one, let's go to that. The session accounting, the time accounting, or the weight-based accounting. Because at the end of the day, they both come from the same source. And that's why they're probably easy to do. And it will be ridiculously simple for you to actually go and do that very quickly. Let's see how you can do that. A process in Oracle can only be in 3 different states. That's it. It's doing something useful. That means it's consuming a CPU, for example, doing some calculation, getting something from the disk, or trying to find out the next available block in the buffer cache, etc., etc. So let's call that U. That's been doing some time useful. Or it's doing nothing right now. Why? Because it's waiting for some work to be assigned. But the session gets connected to Oracle. Oracle doesn't have to do any work unless you give it some work, unless you give. So you're just connected and doing nothing. That time is idle. Or the third one is that it's not really idle, but it is waiting for something. For example, it has given the instruction to get a block from the disk, but the block hasn't come yet to the buffer cache. So the Oracle session is waiting for that block to be available in the buffer cache. Or it requires a latch to retrieve a block from the buffer cache, but at this point, the latch is not available, somebody else has it. So we're waiting for the latch. Or it could be waiting for a row level lock, which somebody else has locked it. So it's waiting for something to happen. So let's call that W. So if you draw an analogy to, let's say, your situation, let's say you commute by car from your home to your office every day, and it takes you half an hour every day to come. Suddenly one day it took you 1 hour. Then next day after that it takes 1 hour as well. So somebody asks the question to you, hey, you used to come half an hour, now you're taking an hour to come, so what's going on? So you say, well, now I'm taking more than 1 hour, and I used to take half an hour. So the person who asked the question says, well, there's a problem. Then buy a faster car, buy a Ferrari or a Maserati or a Lamborghini, so it can come faster. Is that the real answer? If you buy a Ferrari that can go 300 miles an hour or maybe more than that, can you reach the office faster? Maybe, but doesn't have to be. Let's see why not. Let's say when you get out of your house, if you take a stopwatch and you measure exactly what you did when you got out of the house and reached the office. Well, you got out of the house, you meet a stop sign. No problem, you just move on. Then you hit a traffic light. At the traffic light, you waited for about 2 minutes. Then you went. Then you hit the traffic, very heavy traffic on the road. The speed limit was 30 miles an hour, but you couldn't go more than 20. And you were stuck behind a car for a very long time. And that's what. So you keep on measuring it. If you add them all together, the time comes to 30 minutes. But let's say the problem started happening. If you took this stopwatch and you keep on going, you'll see, okay, you got out of the house, you reached that traffic light, you waited for 2 minutes, but right after the traffic light, there's a construction going on. There's a road work going on the road. So at the road work, 2 lanes of the road were narrowed down to only 1 lane temporarily, and that's why the police stops the traffic on both sides and let go of only one person at a time. Well, as a result of that, you were waiting behind that for half an hour. So that's your problem. Now, if you had a Ferrari, would you have covered the distance in less than half an hour? No, because you were stuck in a different problem altogether. So this is exactly where you have to figure out where is the problem. Now, in Oracle database, the same thing happens too. If a session is connected and is taking, say, half an hour to do something, and suddenly one day it took 1 hour to do something, it doesn't mean that the CPU not available or memory not available or disk is not fast enough. Those are possible. That's quite likely. But unless you find out exactly what it was waiting on, you can't really figure out how to solve the problem, just like you solve your traffic problem. So in this your traffic example, the solution is really simple. Find out a different way. If you buy a Ferrari, it's not going to solve the problem. Just like that, if you're waiting for a lock to be available in a database, buying a faster machine is not going to solve it. Or buying a faster, much faster I/O system is not going to solve the problem. At the end of the day, you have to solve that problem that the system is waiting on, not necessarily making it faster. So you have to find a different route so you can avoid that road construction site and then go around it. Buying a Ferrari is not going to help you. So, or let's say a different thing. Let's say you take a freeway or a motorway or the interstate highway, I mean the highways, which is there is no traffic signals or anything else. So you go pretty fast. Let's say in America, our speed limit is not more than 65 miles an hour. Sometimes they're 75, but mostly 65 miles an hour. You cannot even go further than that. But in Europe, for example, autobahns, so they have no speed limit whatsoever. So in that case, let's say you go and there is no traffic on the road and you go, but your car can't even go more than 65 miles an hour, maybe 70 an hour. In that case, buying a much faster car like a Ferrari, which can go 300 miles an hour, will make a huge difference because you have the resources and you just simply put more resources to go faster. So you got to understand what exactly the problem and solve that problem and then go for it. Now, is that difficult? Well, that's my point though. It's not difficult at all. It's very easy in Oracle because Oracle is a chatty product. It keeps telling you constantly what is bothering it. It's like this way. If you go to a doctor doesn't have to ask you anything. Doctor has to simply listen to everything. Your heart tells you, here is my number of heartbeats per second. Your wrist tells the doctor, here's the number of pulse. Or here's the blood pressure. Here is the cholesterol, whatever. Just imagine that. This is just constantly talking to the doctor, and all the doctor has to do to listen and get the diagnosis right there. Same thing in Oracle too. Oracle constantly talks to you. You just have to listen in the right places to get that. So how do you get that? Well, this is a thing you have to get that. You have to listen for three things. If the session is doing something useful, if it is not doing something useful, is it idle? That means it's waiting for something to be given to it. And if that is the case, you can't really blame the database server for that. Maybe the application server is the problem. That's where the bottleneck is. So you have to solve the problem there. Or it is doing something, is waiting for something. For example, block from the disk, a lock, etc. So you got to solve the problem in the right places. I have seen, let's say, you have an application server that runs a Java virtual machine, and that is a CPU contention in a Java virtual machine. At that time, the database server is not doing anything. It is idle. It is waiting for something to be given by the Java virtual machine. But JVM is stuck because this is a CPU contention going on at this time. So that's a fundamental problem we have to solve and find out exactly where the problem lies. And how do you solve the problem? How do you find out? Well, it's actually ridiculously simple to find out. So to find out the response time, of the total response time, we have to measure U, that is useful time spent doing the time spent in doing useful work. I, time spent in idling because no work was available. And finally, time spent in waiting for something to happen. You combine that, and only then you figure out where exactly the problem is and how do you reduce it. That's the concept of performance tuning in Oracle. You must always start with this principle. So let's see what it is then. Well, where exactly do you find it? Is it that difficult to find it? Or do you have to pay money to find it? No, it's not. If the information is available there, right there in front of you, in the view, you must be already familiar with $3 session. Before Oracle 10G, this information is available in a different view called $3 session _ wait. But from 10G onwards, this is no longer $3 session wait. You can get that from $3 session. So here is the query you should be using. Select SID, event, date, wait time, seconds in wait from $3 session. The event column is the one that shows you what exactly it is waiting on right now. But here's a big difference. It also is there if it is, but here's a little thing you have to be careful about. The event column shows you what the session is waiting on right now. But if the session is not waiting on anything right now, it is doing some productive work, the event column could also be populated. In that case, it shows you what it was waiting on earlier. So you have to be careful. Now that brings you another question. How do you know then if the session is waiting for something to happen or is doing some real work? So it's impossible to find out. No, not really. That's where the next column comes in. But before you do that, this is how you do the wait time analysis. Seconds in wait shows you the waits happening right now. If a session is waiting right now, the seconds in wait will come into picture. For example, in your case, you took the car out of your house, you got to the end of the road, driveway, you are onto the road, but you can't go get in the road yet because there are cars coming from that direction. So you're waiting for the cars to pass. So if you had a stopwatch, at that point, you'll start counting from the time you started waiting on until you actually get on the road. That seconds in wait shows you what's waiting on right now. But if it is not waiting right now, you are on the road doing productive work, how much time you waited earlier. Let's say you waited about 30 seconds to get on the road. That would show up in wait underscore time in the same view. So earlier that gets a little confusing then. So in that case, how would you know if a session is doing productive work or non-productive work? It's important to understand that as well. And some people get confused. Well, I can look at status column. If that is idle, it's not doing something. If it is not idle, active, then it's doing something, it's doing some productive work. Not true. A session status, active or idle, that simply tells you session is working or not. A session could be idle, but is waiting for something. A session could be active, could also be waiting for something else. So status column doesn't show you the thing. What then shows you? Well, what shows you is the column called state in the same view called $session state. If the state column shows you waiting, the session is waiting on right now on that event. So you should look at the event thing. If the state column shows you, and in that case, how much time it is waiting on so far shows up in seconds in wait. Imagine in either case, you got the car out of your garage, you went to the driveway, but then you were stuck in waiting for the cars to pass before you go on the road. In that case, somebody had to ask you, hey, how long have you been waiting? So I've been waiting for 50 seconds. So that 50 seconds will come in seconds in wait. If the same question is asked maybe 5 seconds later on, and that response will be 55 seconds, and so on and so forth. So that's why if it is said is waiting, you should look at seconds in wait. In that case, the wait time column is not relevant because it's not really important in that case. All right, let's go to the next one, which is if the state column shows you waited known time, that's a big difference. In that case, it shows you the session is not waiting at all. It is doing some productive work right now, but it had waited earlier on something. What was that something? Well, it waited earlier on that event, whatever it shows you. So in this case example, let's say you got off your driveway, you waited for the cars to pass, and then the cars were gone, and you jumped on the car. You're on the road right now. At that point, if somebody asks you, hey, what are you doing? You're not waiting at all. At that time, you're doing productive work, being on the road. So in that case, you would say, I'm working. In that case, your state column would say waited known time. But the next question is that if you waited known time, then seconds in wait makes no sense because that's not relevant. In that case, what is relevant then? The amount of time you waited earlier, let's say for 55 seconds you said it earlier, that would show up under waited known time. Okay, sorry, the wait underscore time. Sometimes the wait time is so short that Oracle doesn't have a chance to measure it yet, let's say less than a millisecond. In that case, Oracle puts a value called waited short time and puts the value -1 in wait time because it was too quick to measure it. But waited no short time also means the session is waiting for right now. Now, I don't know about you, but I always get confused with all these explanations. So for me, a flowchart makes a lot of sense. So this is how the flowchart looks like. Look at the column called state. If state is waiting, check for seconds in wait. That means the session is doing waiting for something. It's not doing a productive work. If it is waited known time, then the session is doing some productive work right now. It's not waiting. But in that case, check wait underscore time to find out what the session was waiting on when it did the wait, what on right now. If you see waited short time, again the session is doing productive work, and in that case wait time would be -1 because it's doing productive work right now, but how much it waited earlier, it was too difficult for Oracle to measure it. That's the reason why it did the -1. So hope this kind of makes sense to you to make it very, very quick. Okay, to see that this should be a fundamental. So how do you find out the session is waiting or not? Well, this is how you do it. Select SID, state, event, and wait time, seconds in wait. Never ever select event and wait time and seconds in wait without selecting the state. This is the most confusing mistake people do all the time. I've seen it. They always select event and wait time or seconds in wait without selecting the state. The state tells you if a session is working or not working. Without that, you can't really infer what the problem is with the session. Okay, so what are the different common wait events then? Well, DB file sequential read is an wait event typically. So in this case, the session is waiting for an I/O to be complete. At that time, is waiting for I/O to be complete on the disk to the buffer cache, not on the buffer cache itself. Second most common thing I've seen is that ENQ TX row lock contention. It's a session is waiting for a row held by a different session. At that time, until the session or the session commits or rolls back, this session is not going to do anything. And at the time, so you got to find out exactly what is waiting on, and then you can tell the appropriate people to take care of that one. Log file sync. A log buffer is to be flushed to the disk. As you might know already, a log buffer is flushed to disk on 4 different conditions. Every 3 seconds, every 1 megabyte is getting filled in the log buffer, 1/3 of the log buffer is getting filled, or a checkpoint happens. So these are times the log buffer gets flushed constantly. And if the I/O is slow for some reason, the flush to happen, then the session's waiting for, the fourth one is commit happening as well. And if the I/O is slow, that the commit has to wait until the log buffer is flushed. Until that happens, the session waits with the log file sync. Latch free. Session is waiting for some latch. For example, a session already knows that the buffer is available on the buffer cache. It doesn't have to go to disk to get the buffer. But in that case, it has to get the CBC cache buffer chain latch. Before it can go and identify the buffer in the chain, it has to wait until the CBC latch is available. Or finally, the thing is a SQLnet message from client. Now, this is an interesting wait event. Remember, imagine this. When a session is waiting for work to be given, for example, if session is connected, but you haven't done anything yet. Let's say you haven't. But you are saying select star from EMP. That's the actual work given. Until the actual work is given to the session, it's going to wait. At that time, it will be idle. But you might think about this from a session's perspective. How does a session know that you, as the end user, actually haven't really entered any command? Or is it possible you entered the command, but Oracle hasn't actually got it in his own system yet because of the network problem in between? So from Oracle perspective, it doesn't know what exactly is going on. Is it because you are not entered any command, or is it because the network is so slow, it hasn't got the command yet from you? So from Oracle perspective, it doesn't know that. So it says, I'm waiting for something to go over the network to me. That network, as you might know, is SQLnet. So every time Oracle is waiting for some work to be given to it, it says, I'm waiting for work to be given to me over SQLnet. So if you see this wait event, SQLnet wait event, it generally means the session is idle and is waiting for the work, but not all the time. If there is a problem, real problem with the network itself, then you would also see the exactly same wait event because it's waiting for the specific client. Okay, having said this, so there's a multi different wait events you can see. So how do you find out which session is locking the row? Next one is find out. But before we do that, let me show you a little demonstration of how actually this works. So please bear with me when the demonstration is working on. Hopefully this will work fine. In this case, excuse me, I have, suppose I have 2 sessions. I have a table. Let me just give you the table name here. Add setup. I did earlier called test 1, test 2, test 3. Suppose I did that, and I gave it a table called test 1. In this table test 1, I did an update on one session. See that I did the update T1 set column 2. I did not do a commit in this case. So that means this session is going to hold the lock on that particular session. Let me go to a different session at this time, and this session here, and do exactly same thing. Let me just say echo on so you can see exactly what is going on. UPD, update T2. I did exactly same thing, and this is hanging. Why it is hanging? Well, it's very simple. This is hanging because the first session here, I did the update here, I did not commit. As a result of that, there's a lock on this by this session, and therefore this system is going to hang. And you know, at this point, a developer comes to you and says, the database is slow because a lot of things are hanging. So you have heard that, I'm sure, 1,000 times, database is slow. So what do? This is exactly where the confusion comes in. People say, oh, let's go start a top session, AWR report, etc., etc. No. When your database is slow, the first time you hear this thing, you got to understand something. The database is never slow or fast. It goes at a constant speed. You are either slow or fast based on something happening to you. You got to find out at this time why this particular session is waiting for something. What is the problem with the session? That's the reason why it cannot go forward or is it slow. So how do you find out again? Remember our wait event analysis? It can be only in 3 different states. Doing some productive work, waiting for some work to be given, which is idle. And the third one is waiting for some particular resource or a thing to be available. That's a wait. So you got to find out what exactly it is waiting for. And we also saw how to get that information. Well, let's get that. So at this point, I got a complaint that the database is slow and therefore I have to find out what's going on. I don't need to. The first thing I should do in this case is I go to SQL Plus on my using sys and say, I'll show you the command so you can see that. I will give this command. Select state event SID seconds in wait and wait time from $session. Where, by the way, I may have to narrow it down to say username that is using it probably in this case. Okay, let's see what's going on here. Look at the SID 69 in this case. Let me just maybe try it here. Pane, okay, 69 here. What is 69 state? State is waiting. This is exactly what we wanted. State is waiting. And what is it waiting on? SQLnet from client. As we knew from before, there are only 2 reasons. One, it could be really waiting, it's idle, or it could be some network problem. So most likely it's not a network problem. In fact, that's probably very rare. So it is where idle is waiting for some work to be given. What is the other one waiting? 73. 73 is waiting on again, state equal to waiting, it's not doing any productive work, and is waiting for this particular event. ENQTX row lock attention. That's exactly what we find out is the problem. And next question is that how long has it been waiting for? Well, it's waiting for 119 seconds already. And if you do this command one more time, sorry, hold a second please. Drawing normal, non-drawing mode. If you do this one more time, oops, look at this number. This 211 is now the wait time is 211. If you keep on doing it, it'll keep on increasing. Because every time you select from it, it says, hey, I'm waiting for ENQTX roll-up intensive, and I'm still waiting. And that's why the SID is 73 and waiting for that. Continue to happen. So you see that? So now I narrowed down my problem. Listen, 69 is not a problem. 73 is waiting for something. That means the database itself is not a problem. It's something your session is doing. That's what the problem is, and your session is the one waiting for something. So in this particular case, your session 73 is waiting for a row lock, which is held by somebody else. So that's why suddenly the problem came down from, oh, database is slow, to a very simple soluble problem, which is in this case over this one. Now, in this case, next question they will probably ask is, well, if somebody is locking something and I'm looking for that, and that's why I'm waiting for row lock, who is locking it? Isn't that the next obvious question? Now, how do you find it out? Again, the information is available right there in the same view you saw before, $session. And here is how you should say. Blocking session, and if it is a rack database, that's quite possible that the SID blocking that, it could be in a different instance. In that case, you should look at the blocking instance as well, and from seconds in wait, from schedule session, who is holding the lock. Let's go and do that. So now that I know who is doing this thing, I will go and find out very quickly. In this case, I'm waiting for 73. 73 is the one waiting for it. There you go. 73 is a session waiting for row lock. The row lock is being held by SID 69. That's why now I know 69. So that I certainly tell the end user that whatever you're waiting for, that thing is being done by being held by 73. I'm sorry, by 69. Okay, this is good. So far, so good. But what else? Once I know the SID, I can get a whole lot of things about the session. For example, who is the user? Who is what machine it is coming from? What, how long it has been connected? Is it even connected? What are the SQL ID? What was the previous SQL ID, etc. and etc. What programs are they using? This is all kinds of stuff that can happen from here. So let's do that. A few things here. So 69. So for example, let me find out what things are executing. Well, 69 is executing this statement right now. Oh, there you go. Update T1 set column 2. And what is our other one doing? 73. What is that doing? Well, there you go. This is doing right now. Update T1 set column this one as well. So as a result of that, it looks like they both are going after the same particular row. Well, that's the reason why they're holding it. But from $3 session, you can also find out a lot more information about it. And that's the reason why it could be waiting. Let's just go back one more time here in this case. In this case, what I've seen sometimes is people connect using virtual private network, VPN connectivity, and then they don't realize that the network connection got disconnected somehow, but the session hung around. So they did that update, got disconnected, the session hung around for a long time, and until they can't even do a commit and roll back because then the session is disconnected. So at that time, the DBA may have to go and kill the session to release the lock. But again, what I'm trying to say is that you found out the problem by doing a simple calculation, simple looking around here, and you solve the problem as opposed to going after everything. This is this very simple problem, of course, and you get that. Let's say once you get that row lock containment, so you found out who is locking it. The next question they might ask is that, well, this is a very simple statement, update T1. A typical application may be a little bit more complex than that. So you want to find out exactly what table, what row was locked. Okay, and you're going to get that. So in this case, you can find out very easily using this particular select statement. You can see that I'm selecting from the DB objects. I got everything from there. The row lock, row weight object number, row weight file number, row weight block number, and row weight row number. That you can use those information to construct the exact row that is being locked. So how do you do that? So in this case, we know 73 is the one waiting for that. Well, there you go now. So we got the table. What is it? Is a table? Is a table called T1. If it was a partition, we get a partition number 2, and here is the row ID. So once you get the row ID, I can find the primary key of this table, and by using this command, row ID, row 1, and here is a table called ARUP.T1, and row ID, I'll simply copy this information over here and paste it. That's it. I got this thing. Now I can tell the entire information to the user, saying that, hey, listen, you are waiting for an update statement on this particular table and row, and therefore, until the other person who has done the update commits or rolls back, there is nothing you can actually do about it. So it is quite possible to have a programming flaw, so the first one doesn't commit after a very long time. That is possible. Or maybe the other person might have disconnected and without knowing about it. That's why you're holding on. But so either way, you know exactly what the root of the problem is, and you can fix it. So that's the most important part of a troubleshooting. And you saw how easily we just figured out everything using this simple this thing from all the simple views from VSSESSION. Again, you get everything from here, from here, SQL statements, etc. So this is a very common wait event problem, and by using this thing, I've seen we can probably solve about 60% of the performance problems using this approach as I mentioned to you. Now, of course, that doesn't mean that this is the only problem, is a locking problem. There could be other problems too, like latch, etc., and etc. But again, the approach is the same every time. And this is how you should do it. Find out what the session is doing right now. Is it doing productive work, or is it waiting for something to happen, or is it idle? If it's latter, like is idle or not waiting for something to happen, what is it waiting for? And then go from that point onwards. If it is a lock, we find out exactly how to find a lock, who has logged it, what exactly row, etc., and you can find out as well. This is how you should be doing a troubleshooting. Now, sometimes that's not the case. Suppose at some time somebody tells you, hey, it's a problem right now, and the sysadmin tells you as a DBA that the CPU consumption is 99% on this box. Well, what is going on? That's great. Find out what's the problem right now. What happens when you see a 99%? So the first thing you should do is find out in the top command who are the biggest CPU consumers in the process. If you see that Ora underscore in there in the name, that means this could be one of the Oracle server processors. Well, the next question is to find out why are they consuming so much. Well, you can do that by using this. In this case, you got that machine state, etc., to find out. Once you find out what process they're using, let's say process number is 1, 2, 3, 4, 5. That's a SPI, the process ID. Use this script I'm showing you on the screen right now. Replace the SPID variable with that process ID you got from the sysadmin. That will tell you exactly what the session SID is for that one. Now, once you have the session SID, you can find out very, very easily how much time the session has consumed, how much that came from that particular session, etc. Now, how do you find out how much CPU the session has consumed? Is it difficult to find out? No, you don't. So you go to another view called $SSStat. SSStat is actually a view that shows you what are the statistics of that session. For example, number of CPU ticks consumed, number of logical IOs, number of physical IOs, etc. And so latches, etc. Everything about a session, you will see that. The problem is that it has a statistic number, not a name. So you have to combine that with another view called $stat name, where it also has statistic number, and that has a column called name column to show you exactly how the different to get that information directly from there. Here is an example of how I'm doing it. So I'm trying to find out what is the CPU consumption by the session. So here I put the SID, I replace the SID with the appropriate SID, or some of the statistics like session logical rate, etc. That will tell me very quickly why is session consuming so much of CPU or so much of logical I/O. It could be somebody is doing a full table scan. Somebody has forgotten a where condition, a predicate, or somebody is doing a Cartesian product of two things, and that could be the reason why some statistics are pretty high. But again, you found out using the right tools, using $SSStat. Just like the SSStat, what about other things in the entire database? So you might want to combine the SSStat statistics from all the sessions, but would that give you the overall database session? No, you don't. Why not? Because SSStat is only for the duration of the session's existence. When you disconnect, SSStat also goes away. So if you select from the SSStat about a particular statistic, that will give you a snapshot right now how much the session has. All the sessions consumed so far, but not the ones that got disconnected already. So to find out about the entire database, actually for instance, not entire database, this is what you have to do. Using something called SysStat, that's for the entire system. So it's SysStat level. In this case, SysStat, it tells you entire system. So you have to find out if the CPU consumption or the logical I/O or something else is creeping up or are they constant state. If it is creeping up, you got to find out, drill down to SysStat to find out which session is doing that. session events is another one. Now we saw the session, we saw that before that you can actually find out what a session is waiting on. Now what happens is that when you go in there, you see the session is waiting on SQLnet for client. Now in this example, let's go back to our demo. So in this demo, it was waiting on, but by the time you went there, so in this example, this session has done a rollback. Now if you look at this thing now, this session now, this row got updated. This was waiting on before because this thing was not waiting for anymore. So if you go in now, in this case, and find out who is waiting for what, you'll see, well, they're not waiting for anybody. The SQLnet from client is actually an idle message. It's not waiting for anybody. Why? Because they have done waiting. But the problem happened before. So it's not something, if you look at them right now it is gone. So how do you find out what the session has been waiting on before? Is there a way to find out? Absolutely. And that is called $3 session_event. That tells you what it is for all the session, what has been waiting on, how many times has waited, how long has been waited, what is the average wait time, etc. and etc. So let me show you that very quickly. Event for, let's say, for 73. We know that is waiting on that. Look at that now. It shows me very clearly this session has been waiting on ENQTX roll or contention for 926,000 milliseconds or 926 seconds or something. Or on that is average wait has done only one time. SQL message to client, disk file operation IO, etc. has done that. So from here, I can tell you, I know this session has been waiting on a roll or contention for a very long time, even though right now it is not waiting on something. That's called session event. So here is another example. In this case, you can show in this clearly that, hey, you have done some roll or cache, row cache log, library cache pin, etc. for a long time as well. Just like there is session systat to systat correlation for the entire system, you also have something called zero system event for the entire database as well, not for the system we're looking for here. Sometimes it makes sense to have for last 10 wait events. You can do that from session wait history, because if you look at this session event here, what is that thing? In this example, is session event right here. Sometimes in a typical system, you would see a lot more wait events, so it might not be worth it. So Oracle captures the last 10 in a different view called this view, session wait history, because that sometimes the last 10 wait event could be the most relevant one you're looking for. So it's probably one of the quick things to start with. But here's the problem though. Where session event shows you that something happened, it doesn't show you exactly what time it happened. For example, in this case, we saw in this output before, we saw that this session was waiting for a roll of contention for 926,000 milliseconds, or 926,000 seconds, which is good. But doesn't tell you when. It happened 1 millisecond ago, happened 2 hours ago, happened 3 hours ago, 10 hours ago. You don't know that. So if you're trying to find out a problem, it might be helpful, but might not be completely helpful because of this reason. So to do that, Oracle actually provides a little bit different view called active session history. So what it does, it selects the information for all the active sessions every second and puts into a buffer in the memory called active session history, or ASH buffer. So after every second, after 10 seconds, it gets flushed into a disk and go to it and stay right there. So this is the active session history. Generally, you have about 30 minutes worth of active session history in the memory itself, so you can get it very quickly. And after that, it goes into the disk. Now, ASH can tell you what happened at a specific point in time. That's a very, 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 very useful tool for that one. Let's look at that. How is my ASH history is available? So in this case, it doesn't tell me what time, but it. Oh, sorry, I don't have ASH history. Let me just 1 second, please. AWR. Oh my God. Okay, I don't have the information on ASH. Host dir. I don't have ASH information. Okay, so then we just have to see that in this case. So ASH simply tells me what time it happened. The problem is that It's a part of the diagnostic and tuning pack, which is an extra cost option in Oracle. If you don't have it, well, you have to buy it. You don't have the information to that. But if you have it, you should definitely use it because you can go back and find out exactly what happened in each of the databases at a single point in time. Now, sometimes what happens is that somebody complains to you that, hey, my application is slow for some reason every time I run it. So one thing, of course, you can watch it when they run it and you can see that constantly, but it's not possible to watch it constantly. So what else can you do? It's a very simple thing to do. You trace it. So we all know SQL trace, alter session, SQL trace equal to true. It will start tracing. What happens if you cannot alter the code? Alter session means you have to put a code called alter session in the program. In a third-party application or your own application as well, which is compiled already, you can't just put it there. And sometimes people tell you something that there is a problem or you have to trace it when something is already running. So it's something you cannot do. So how do you solve it? Well, it's a really simple thing to solve it. From Oracle 10G onward, there's a tool called DBMS Monitor. Again, this is free, no cost. And you do this way. Session trace enable. You give the session ID, SID, and serial number. You say waits and binds equal to true. It will create you can do that from a different session, not in the same session which is you're supposed to trace. You can do that different session and it will start tracing and it will give you clearly what happens every time. For example, it retrieved one block, it took 1 millisecond. It retrieved 20 blocks, it took 20 milliseconds. It retrieved another block, that one took 50 milliseconds. There you go. So just to get one block, it took 50 times more time than it had before. That's a fundamental problem. So you have to find out exactly what the problem is. That's the DBMS Monitor. Once you have that the trace file, how do you? So you say not exactly human readable format. There's a tool called TKProf. Then user ID and the password, and you put the TK input file is the one uses the trace file you got generated, and you can put the output file name. That's where the file will be created to give you a human readable output. It's a text file that will tell you precisely how much time was consumed by each of them. Now, trace is good when you don't want to watch it in real time. You kick up the trace, let trace collect all the data, you let the program finish, you get the trace file, you analyze it afterward to find out exactly what the problem was. This is sometimes very, very useful to do some troubleshooting for badly performing queries. So in summary, find out what is the immediate symptom right now. Is it CPU? Is it IO running high or a specific session is slow? Database is slow means nothing. You got to find out exactly what is the one that is slow. So based on that, you take your next action. So for example, in this, we saw two different cases. We saw one case, the IO, the locking contention. One session was holding a lock, which other session was waiting for, and therefore the other session was slow. Actually, it wasn't slow. It was waiting for something, and that something was a lock. So by using the right tools, right information, you told the developer or the application people exactly what the reason this session was waiting for, and then you could fix it. In another example we saw before was a resource contention. That was the CPU resource. Again, finding out the right information, you also from visualization stat, etc. You can find out also from visualization and visual process. You could find out exactly what Oracle SID was contributing to the CPU or IO, etc. So those are things you have to understand to find out, and based on that information, you can tell the end user what to do about it. So this is the methodical troubleshooting we should be doing for all the cases. In my experience, what I just told you, it looks like very simple. It is actually very simple because Oracle provides everything to you is available. It solves about 60% of the problems you will encounter in your typical career. Of course, you can't solve everything using this approach, but that's not the point. The point is that you can use somewhere and then expand on it. But about 6 out of 10 times, the problems will be solved by using this simple technique I just mentioned to you. And how many things I told you? Visualization, sestat, process, session event, and all the corresponding system event and sestat as well, and active session history. That's about it. Nothing more than that. And using this simple few tools, you got everything that you need to do. And I will be actually more than happy to give this put all the scripts on my blog later on. You can download it anytime you want and get the information as well. But keep them handy and keep them and to solve the typical performance problems. So with that, I thank you very much for listening, and I'll open up for questions and answers. I'll just put my blog over there. These things are not there in the blog yet, but I will eventually put it. And I put my Twitter account as well, and scripts, just put it here. So when the time comes, you will download from here. Francisco, if you could just read up the questions for me, I'll be more than happy.
Yes. Can you hear me, Arup?
Yes, I can.
Okay, I have one question only at the moment. If more people have questions, please feel free to ask. Si alguien más tiene alguna pregunta, por favor, que la mande por interno o la parte de preguntas. In this case, Arup, is a question for Arturo. Arturo wants to know how he can monitor hang sessions. One example. Client is using a database link to do a DML transaction on a database B through the database link, and the session get cut. Then the client tries to reconnect the session again and try to process the same DML, let's say one example update, and is hung because the previous session that he tried is still running right there. It's not commit, it's not killed by the server, and that's why it's causing the new connection to hold, to wait.
Great
How
question.
we can identify
I got that. Yes, great question. So this is a typical problem, happens all the time. In fact, it happens usually when you use VPN to connect from home or remote access as well. Because this is typically where your session gets disconnected, sorry, your internet connection gets disconnected, but your session is still alive and done the update already, and you can't do anything about it. So the first thing is that the word hung is to remove it. Nothing is ever hung. It's either slow or waiting for something to happen. So the first thing to find out is that, so what exactly is really going on with the sessions? So first thing I would do, use my script. I showed you the wait script here, the first one. Let me just give you that one more time. This one. So this one tells me I have no idea what's hung, what's not hung. This one tells me at this point that what are the different states of the event and all that thing. Here I put username equal to Arup, but you don't have to if you don't know the username. So just get everything here. Now if it is really hung, you would see the session that is hung is waiting for something. And that you would see over there, ENQ roll lock contention. So that's what we just saw before. So once you find it out, the next thing you find out is that, okay, who is holding that lock? So you saw that before as well, using this thing called block. This thing we saw before. Sorry, this one. Yep. This is the one we said, so who exactly, which row is holding it, and which other session is, oh, sorry, there you go. This is the one we said. So this one in this case says 73, which is not holding right now. But if there is really waiting for some roll of contention, this will tell you, this command will tell you exactly which session is the one holding the lock. Then once you hold the session, you can find out from there. Select. So say select status, comma machine, etc. from $v session where SID equal to 65 or something. I don't know what it is. So you can see that here. If it is session got disconnected earlier, you would see status equal to inactive at that time, and the machine you know exactly where it's coming from, etc. So at that time you know this is not connection no longer exists, and then you find out exactly why this happened. Now if you can also go further and look at another view called $v process. In this case, that's the actual process, the Oracle server process the session is connected to. So in this case, you can see here, select ADDR or something, SPID, not that, it says describe $v session, SPID1, and another one, PID1, okay, I don't have this, So you can combine these two sessions from VDR process. You combine the ADDR and you combine that with $V sessions PADDR. Let me just go up there. The PADDR, that's a process address. So you combine that with the $V processes address column to find out what is the OS process ID that this is connected to. In a typical Unix system, you would see the PS-AEF graph for that. You would find out what is the parent process. If your process is disconnected, but the session is not, you would see the parent process doesn't exist, or the parent process shows as 1, which means is now is the background process. So you know that's how to, that thing is not going to come back, so you would have to kill it to release the locks. Okay?
Yes, thank you so much, Arup. Anyone have any other questions to Arup? ¿Alguien más que tiene alguna pregunta que quiera hacerle a Arup antes que terminemos? Okay, looks like, Arup, we don't have no more questions. Thank you so much, my friend, for giving or share your time with us. It's always an honor to have you here showing a little bit of your knowledge to all the community. Thank you for all the hard work you do with the community all the time, and hope to see you soon.
Very good. Thank you, and hope to see you soon. Thank you, everybody, for joining today. I know it's a little bit late, so I hope you enjoyed, and hope you. And again, I'll be putting the blog entry. So, Francisco, will you put this session on your website? I can send that to you.
Yes, that will. Well, yeah, that's no problem. I will be publishing the video internally in the OracleMania community, and I can also add everything else there if you want it.
That'll be awesome, and I'll send that to you right away. Great. Thank you.
Yeah. Thank you so much. Thank you, everyone, and have a good night, everyone. Bye-bye.